Welcome to our second awesome episode of Live Behind the Bricks. I'm coming to you today live from Billund, Denmark, and I'm really excited to see so many people have logged in online for today's session. I know some of you will be watching this replay, so a very warm welcome to you from wherever you are and whenever you're tuning in. All right, today we are meeting actual colleagues from our mechanical engineering team. And I'm going to be asking them loads of questions to find out what it is that they do, how they do it, how they apply play to their everyday work. Not all the questions are from me, though. You can ask questions too. If you see there's a little box with a question mark in it, I think, where you can drop some questions, drop those in the Q&A, and then we'll try to get to them. If we don't get to them, don't worry about it. My amazing producers who are behind the scenes, they're capturing all of the questions, and we'll try to get to every single one. Either in the episode today, or they'll get back to you in the chat. So let's get started. From the magic of today's modern podcasting technology, 5 of my amazing LEGO colleagues will now join the screen. And it's working. Wow, amazing technology. That's great. Hi, everybody. Welcome.
Hi.
Hello.
Hey.
It would be super awesome if we just go around and introduce ourselves. We'll do a round, say your name, what your role is, what your job function is, and where you're joining us from today or where you're from, and then hand it over to the next one. So we'll start, Agnes, with you, because you're the one who seems to be right next to me on the screen.
Okay. Hello, everyone. I'm Agnes from Hungary, and I have been working at the Lego factory in Nyíregyháza for almost 5 years. I'm currently a senior EHS engineer. This means environment, health, and safety. And I'm responsible for factory level projects, for example, chemical management, explosion protection, building accessibility, and employment of people with disabilities within diversity and inclusion program.
Wow, that sounds super important. Thank you. Mandana, you next?
So, hi everybody. My full name is Mandana, but Mandi is absolutely fine. I'm actually Italian. I moved to Denmark in April 2017, so it's 6 years and a half by now. And I came here to pursue an industrial PhD in mechanical engineering at the Lego Group. And today I'm actually leading the research and development of metal additive manufacturing technologies for the company.
Super cool. Thank you for joining us. And we have Jesper.
Yes, I'm Jesper. I've been with the Lego Group for 4.5 years now, working as a mechanical engineer in novelty element development. So I do new Lego bricks, designing of those.
Okay, that's also super important. Camille, you're next. Oh, Camille, we're having a bit of trouble with your audio. We'll move on to Michaela while you work on that.
Hello, my name is Michaela. I'm joining today from our Kladno site, Czech Republic. I work at the Lego Group for 1.5 years right now, and my role is technical project manager at R&D equipment development, which sounds complicated, but simply I'm modifying and developing the packing lines for our bricks.
Okay, so you're helping getting bricks out into the hands of all of our
Exactly.
consumers. Amazing. Camille, how's the audio? Want to try again? Yeah, something about your microphone is not picking it up. I think Andrew's on the other side. He's gonna try and help you with that. In the meantime, I'm just gonna ask everybody, when you join, we'll do a proper introduction. In the meantime, I think we'll kick it off a bit here and just ask the kind of the big question. What is mechanical engineering? And in terms of the Lego Group, what does it actually mean to us? A lot of different job functions from all of you. I don't know, Jesper, do you want to kick it off?
It's a big task. You can hear all the different areas we work at. So there's not a specific mechanical engineering area that you only can work at when you work as a mechanical engineer at Lego. It's scattered all over the place. So if it's within environmental work, chemical work in the factory or in the development of Lego bricks, we need them everywhere. So
when you say chemical, are you talking like plastics?
Yeah, because understanding of plastics, but it's also handling of plastics in the production. So it's not only theoretically point of view, it's also the practical point of view, working with it in the daily business.
Okay, I see we have Camille back. Camille, how's the audio working out?
I hope it is going well.
Yes, it's working perfectly.
Fine.
Please introduce yourself.
Sorry for the delay, guys. By the way, my name is Camille. I'm the part of the Lego production in the Lego Group entity, and we are specialized on WOW model and some kind of advertisement from Lego bricks.
Okay, amazing. We were just talking about what mechanical engineering means to us in the Lego Group and what it actually is. So maybe since you just joined again with your audio, you could describe a bit about how that function is and what that really means in terms of mechanical engineering.
For us, or particularly for me, Lego production is something like a hybrid between the factory and actually advertisement agencies. So that means we have also lots of benefits from that, but also lots of challenges like what the client wants, what they demand, what they are working for. And that depends also what kind of Lego model we want to produce, or what kind of things we want to implement into the model. So we work basically with everything what we have in our hands, and hopefully we satisfy our clients.
Great. Agnes, you mentioned something about explosions. Did I hear that right?
Sorry, explosions? Yeah.
Yes.
Explosion protection. Yeah.
Explosion protection. Tell us a bit about that. What is that in terms of mechanical engineering?
I think it's a very important task because the safety is very important from the Lego Group, and we would like to development the safety process and our factory level. So I think it's very important.
Yeah. So you're helping to design systems that we're utilizing in the factories. Is that correct?
Yeah, absolutely. Yeah. The automatization, I think, is very important from mechanical safety and mechanical engineering, and I working on it so long time.
Yeah, and maybe we could talk a bit about the factories. So there's some of you are calling in from the different factory locations. What kind of factories do we have, and where are they?
Yeah, the Nyíregyháza factory is one of those where the entire production process takes place, right through the final packaging. That's why it takes a complex and diverse team to turn small plastic granulates into fantastic Lego sets that children can enjoy. All enthusiastic and powerful engineers are welcome to join us on this existing journey.
Michaela, you said you are also joining from one of the factories, yeah?
Yes. I'm joining from Czech Republic, from our Kladno site. However, I'm part of the global R&D equipment development team. So we are co-located, which is helping us a lot to be in touch with our colleagues in the plant and, let's say, understand their challenges. And actually, we are here to modify the lines and bring them new future by using the sustainable packaging materials. So it's really exciting. It's very important for me that I can, let's say, jump into my safety shoes and go and see the packing line, because this is what the mechanical engineering is about. Because you want to see the issue, you want to solve it. It's like solving the riddles. Yeah. At the beginning, you are like a bit lost. You need to see it, but at the end, you are so happy once you fix it.
Yeah, we've recently changed a little bit about that packing haven't we? Do you want to talk about that? Or should we get into that a bit?
I think you can already find some, let's say, sets on the market which are already having the sustainable materials. So if you open the Lego set, the box, you will see the little, let's say, pre-packs bags with the bricks inside, and those little bags were previously manufactured out of the plastic. So single-use plastic, you open it and you throw it out. And we are already on the journey to transform it to paper bags. So first sets are available already on the market, and this is, let's say, our sustainable way.
Yeah. And Mandy, you talked a bit in your introduction about materials as well. Do you want to?
Yeah, sure. I'm actually, where I'm focusing on is not into the plastic part. I'm the piece before, so I work with metal. As a background, I'm a materials engineer specialized into metallurgy, which might sound like a bit weird when you talk about the Lego group, but we also do that. I'm focusing on how to materials and especially technologies, in particular 3D printing for manufacturing mold components, because the main technology with which we manufacture our Lego bricks is actually plastic injection molding. And to use this technology, we need molds, and molds are made out of metal. And and that's where I'm working on how to manufacture molds for manufacturing Lego bricks.
Okay, wow. So really at the beginning of the process of the brick. So there's a lot of, it seems like there's a lot of different technologies that are going into such a simple, little 2x4 brick that, I mean, how many different technologies are we talking about here? And maybe we could talk a bit about where they're produced, and if anybody can just tell me all of the factories that we work with here. Yeah, go for it. Don't be afraid to talk over each other.
There's a Belong factory, right? Near Jessa, Kladno.
Yeah.
The Mexican.
Jiaxing.
Yeah, Chichi. Yeah, in China, and the Mexico factory, and I know there are some other factories in the pipeline as well.
Yes, we just broke ground on factories in Virginia, in the U.S., and Vietnam as well, right?
Yes.
Yeah.
Yes.
In
Amazing.
Richmond.
Cool. I just got all of those factory lists came in on the chat. So.
It's not something we work with every day, at least not me.
No. So I'd love to talk also a little bit about what the process is, and maybe there's some things when you start to talk about your processes, maybe you can highlight some of the successes that you've had recently or over the past few years that mechanical engineering specifically is involved in or plays a big role in that part of the process.
So I will start with that, because for us, every project is actually a success. The majority of the projects, they are not repeating itself. So every time it is something new, every time we implement a new material, new technology, new movement, new motors. And in the end, in the factory here in Kladno, the guys, they put it together by hands. So main of the things which we are produced, they are like art of the piece. So each thing is really special.
Yeah, and I'm sure many of you have heard that the Nyíregyháza factory is undergoing a major expansion. New walls have been built recently, new east and west block, and will be soon. So not only do we have to keep up with the day-to-day task, but we also must ensure the safety and planning of new construction work, also the installation and testing of new production lines and machines.
Can you all talk a bit about your experience? how you came to the Lego Group. I mean, what is your background? It sounds like because you're mechanical engineers, I imagine that you all have very advanced scientific degrees and you know have studied. Can you just talk a bit about that?
So ladies first.
Okay, start.
Yeah, Mandy, if you would say.
So as a background, I'm a materials engineer. I studied that in Italy, and after I finished studying, I actually worked for a little bit in the aviation industry. And then after a while, I was actually, my personal wish was to keep my hands on in research. And that's why I've been looking for a PhD. And it was actually great because in the Lego Group, there are sometimes projects that involves industrial PhD students. And that's where I actually applied in 2016, 2017. So that's when I moved here for joining one of these industrial PhD projects. And my PhD was within the mechanical engineering department with a Danish university. That's the Technical University of Denmark. And that's how I entered here. So not really related to the toy industry, coming from toy industries or anything like that.
Okay, so were you still a student when you came into work?
I was actually graduated, but then I became back a student, becoming a PhD student.
Okay, because we do have student internship programs as well.
We do have a lot of them, and we actually love to collaborate with students, master thesis, bachelor thesis writer, project writer, and it's actually something really great. I work a lot with students. I actually have my students sitting right now next to me, and it's actually something amazing, and we do a lot of those collaborations.
I can see one of your colleagues waving in the background.
My student was saying hi.
Maybe before we move on to the others, can you just tell me a little bit about maybe a big challenge that you've worked on since you came into the Lego Group? Is there something that you face? I have a lot of material in there. I think that some of them are targeted towards you, but I'm going to hold for a second.
A challenge related to mechanical engineering or related to Danish language? Because that was also a challenge when I moved here.
Yeah, okay. Fair enough. But I think more towards mechanical engineering.
Yeah. So I would say, I mean, challenges are something exciting. So I would call it challenge, but not with the negative aspect, like with the negative connotation here. One of the projects that I love to work the most was actually about scouting a new type of additive manufacturing technologies, of course, focused on metal materials and new brands, because we were looking on how to innovate the way we were manufacturing mold parts to how we were printing mold parts. And so I started this kind of large benchmarking project. It was quite fun because I had the opportunity to reach out to people and industries all over Europe, all over the world, actually. And it was a very intense project, but I've actually learned really a lot. And at some point, I started receiving samples from all of these companies. So I've been surrounded by boxes and samples to analyze. It was a lot of work, but it was extremely challenging, but interesting.
Oh, that sounds very fun and cool. Agnes, could you tell a bit about your story coming into the Lego Group?
Yeah, absolutely. And I see an interesting question in the chat part. So I would like to answer also, please. Alexandre. So my own experience as I joined the company as a fresh graduate. I was very worried about how I would be accepted into the team, and I was delighted to meet open and welcoming colleagues. My managers have always supported me and given me opportunities to develop, and this is still the case today. So I would like to encourage all prospective new engineering colleagues, whether they were fresh graduates or seniors, to join us. Because never a boring day at the Lego manufacturing.
Right, and speaking of people joining, there are all types of roles in mechanical engineering, right? There's not just specific mechanical engineering, project management, for example. Somebody had asked a question about, do you have project managers who help with the projects?
Yeah. Absolutely. The supporting areas and the project team are essential for the success of production. I'm sure many, I think it's important. Also, I think the installation again and testing. So I think it's very important task and responsibilities in the project team and welcome engineers.
Mm-hmm. Michaela, you mentioned sustainability when you came in, and there was a question in there about the LEGO Group's overall sustainability goals. I wonder if you might want to take that.
Yes, yeah.
How do they affect your day-to-day work?
As I said, I'm working on the packaging part, so that is clear. And probably I should mention it at the beginning, but I'm not a mechanical engineer by the education, but I consider myself as a mechanical engineer by the experience. So originally, actually, I am chemical engineer, materialist. So let's say I was always close to that, and it's a pretty big commitment to say, okay, by 2025 we will move to sustainable packaging materials. Yeah. And this is really a huge project, which is totally hidden because, of course, you see the outcome, and unfortunately, I jump in the middle of the project because, as I said, I'm here just 1.5 years, and I graduated more than approximately 15 years ago. So I was always close to packing clients, and if you see the quantity of the materials which is consumed by the packing clients, you start to think, okay, at home you see just one piece of the product. But once you see the mass production, you start thinking that this is really a big journey, and the impact is huge.
And so, I mean, I guess maybe you're inspired day to day in seeing that, and how can we improve our sustainability, right?
Definitely, because let's say 15 years ago, we were discussing at the chemical university that one day we will move to different materials, and it sounds like let's say future far away from us, and now it's a present. Yeah, we are living that, so this is really great.
Excellent. There's a question in here about set development. Camille or Jesper, do you want to talk a bit about that? It's what goes into developing or engineering for set design materials.
Yeah, maybe I can put a bit of words into that. The sets are developed by the design department, so it's basically a giant department in LEGO, having more than 1,000 employees, I think, just developing LEGO sets, developing the stories behind the sets in the different themes, and then over the course of a year or 2 years, I actually don't know the time span of those projects, but they of course develop for the future play, and not just the next year. They then identify which bricks they would like to put in the new sets, and that's basically where I come in. I then take the designs they want and then apply the LEGO rules to the bricks we make, and make it so that manufacturing can manufacture a mold. So the department that Mandy supports, I guess, doing 3D printed mold cores, we use that into making new desired features in new LEGO elements, to have special cooling in the molds where they are required, because of course it's expensive technology to use.
Oh, that's interesting, because somebody did ask about cooling technology, if we used special jigs or anything like that in the mold making.
We do, of course. To be more specific, plastic shrinks. When you have a lot of plastic, it shrinks a lot, which affects the visual part of an element. It affects the function of our connectors. So there's a lot of influence from the plastic itself and the cooling in the cores and the molds. So therefore, it's a pretty important area to have really good cooling in the molds.
Can you walk us through the brick process? So let's just take, for example, the 2x4. Everybody knows the 2x4 brick. And from the time that it was on the drawing board to the time that it gets into our consumers' hands, what does that process look like, and where does mechanical engineering come into it?
I would say maybe it's the 2x4 brick is a bad example because
okay, maybe it is a good example.
But it's not. I basically do new elements, and the 2x4 bricks is an old element, and there's actually a process for reordering a mold for old element. I'm not into that area, but I can talk a bit into what we do when we do a new element. So PMD, the design department, gets an idea for a Lego set, in Ninjago set, for example, and they want a really cool new sword. Yeah. They want a really cool new sword, for example, or an axe, or a headgear. Then the department kind of contacts us and explain what they want to do and how the design should look, and then we apply the mechanical engineering knowledge we have and Lego has gathered through many years into what is possible to do with element thicknesses and the type of connectors that are needed on the given element. We then apply those mechanical engineering knowledge into that element and draw that up in 3D. And then another department takes over, draws the entire mold, and if extra cooling is needed, the cores that Mandana or Mandy develop gets put into the mold that I draw the elements for. So then the mold is done right.
Produced, and
the mold will then be done. The elements are going in through a qualification department in Lego, where we measure up all the elements, both function, we evaluate the visual part of the element, the function, the measurements of the connectors, and then finally it gets approved and we start up production of the elements. That's basically where I stop having contact with the element.
And then it's packaged, and that's where Michaela comes in. But somewhere along the line, Camille, it needs to be marketed, right? And then there's certain mechanical engineering that goes into that part of it, right?
Exactly. And I would say we are maybe on the beginning or on the end of the process when we need to advertise the Lego sets or how they should like, how, as the Jesper mentioned, like the new Lego set looks like, the new minifigure or new whatever. So we try to do it as much as appealing for the customers, but not the way that it will be just the elements which you need to buy, but you want to have actually fun to cooperate with them, interact with them, to be excited to touch it or to do whatever you want to do it. So basically, we take what our colleagues do in their mechanical departments and take it as the raw material for our art piece and continue with let's say advertisement agency and advertising our Lego products.
There was a question that came in, and I think we might have answered this last week because we had additive manufacturing. So there's a question in here about 3D printing technologies, and why would you say we're not using 3D printing technologies to print the bricks or to make the bricks, or how does that even compare to injection molding, for example?
I would say we still do, because 3D printing, even for us who take the Lego bricks, it's really unique technology to have something to next day or to evaluate if we do good or bad. So I really like 3D printing. It's amazing technology, but compared to Lego bricks and the molding, it has its flaw. And one of the things is it's not precise too much. there are tendency to delaminate some kind of process. They are not smooth enough. It's still like, you're laying layer by layer, and compared to mass production, it's very very costly, because you need to run as much bricks and Lego bricks and material as possible in short time, and you are not able to do that with 3D printing. At least this is my opinion. Of course, everybody.
Yeah, maybe Andy or Jesper, do you want to?
We actually did a 3D printed element last year, I think, or this year. The old duck was released in the Lego house, right? You could buy it there. But as Joachim says, for industrial purposes, the mass production that the Lego group does, it's not compatible in any way at the time. Some of our molds produce hundreds of bricks a minute, and 3D printed, a high performance 3D printing setup can't compare to that, even can't come close to that, and it's way more expensive. So that's basically the business perspective of that.
Mandy, I think you mentioned additive manufacturing when you're talking about molds, right?
Yeah, because we were talking about, like, when we talk about the elements like Lego bricks, then it's additive manufacturing of plastic and polymers. So that's the technology that you have heard probably in the first episode of Light Behind the Bricks. The additive manufacturing idea that also Jesper was mentioning within this course is additive manufacturing of metal. And there are some limitations that are perfectly valid, for example, the precision. And that's why what we print afterwards is getting milled to achieve, because we work with extremely tight tolerances, dimensional tolerances, because if we want a very precise brick, we need to have a very precise mold. But I think there was also a question, I think, from Alexander, that he was asking about where it makes sense. And as also Jesper was mentioning before, it makes sense when we have some special or some, when we need a more performant thermal management in the mold. So, for example, when you manufacture a mold, inserts or cores conventionally, you need to drill straight channels for the cooling. When you actually print the mold component, you can have, let's say, spiral channels. You can have cooling channels that follow the shape of the Lego brick, of the Lego elements. And therefore, the thermal management, the cooling performance is much more advanced. And that's where it makes sense. And it's actually making a lot of sense, because in this way, we can also manufacture with injection molding more brick per minute. We can in general have better performance. We can have mold parts that perform better. So it's helping our injection molding process.
Fantastic answer. Agnes, when we talk about the production of the brick, somewhere along the line in the factories, we're talking about engineering of the factories themselves or the machinery in there. Is that also part of your role?
Yeah. I would like to mention automatization, because when we talk about the automatization in general, the first thing that comes to everyone's mind is increasing production efficiency. That's why I would like to emphasize that quality and safety have always been a focus for the Lego Group. With automatization, we can keep the high quality of our products stable and make many workflows easier, comfortable for our employees. And furthermore, engineering has a key role from installation through programming, testing, validation, and final go live.
Mm-hmm. If you were looking for mechanical engineers in your teams, what would you be looking for? I'll start with Michaela.
That's a good question. Let's say, as I described, we are solving technical issues, and of course, we are looking for people who are not afraid to learn new technologies and be on the line and spend the time there to understand what's going on. And I would maybe change the question a bit, and I will say what is unique about the culture here, because as I said, I'm still kind of a newcomer, and I have a comparison with other companies, and I can say that the LEGO Group offers, let's say, a safe environment for people who love to become wild and crazy and very creative. Yeah, and you can ask whatever question you want at the early, let's say, days in your role, and nobody will tell you that's a stupid question. And you can bring new innovation on the table. And as I said, I'm originally a chemical engineer, so I have slightly different point of view. And this is unique about the LEGO Group, that we are offering the safe, let's say, space, working environment for people to become really creative and open and bring the innovation on the table, because this is not this is very unique industry. Yeah, you will not find a similar industry or similar companies around us. Yeah, so yeah.
Right, so looking for a lot of different things, especially willingness to be creative, right?
Yeah.
Anyone else what are you looking for in if you're looking for mechanical engineering, or somebody who you'd like to have on your team?
I will contribute to this one because, as Michaela said, you need to find the people who are willing to do whatever to find the solution behind it. But first of all, as it says, people choose the profession and profession choose the people. Sometimes you need to have unique to small pieces and solve that small pieces, because in the bigger scale you cannot do that in the time which you have, with the resources which you have. So sometimes you are looking for the people who look on something, see the problem, and automatically there is like autopilot program running behind him that he already finding the solution for some small pieces of that problem.
Mm-hmm. Anyone else have things that they're looking for?
I can maybe tap in, Jake.
Yeah.
I actually think we're coming up with a position in my department, but that position is someone with a deep mathematical knowledge, and specifically within contact analysis of LEGO bricks. So a really deep specialist we're seeking here, but in general, I would say in my department we look for people who both have understanding of the more would you say soft skill or soft values of a LEGO brick, so the design of a LEGO brick, the feel of a LEGO brick, what the kids really want, because we're designing the brick itself. We're in the end those who design what it looks like, but also have a deep understanding of injection molding and 3D drawing skills. So a bit of a combination. We're actually sitting smack in the middle of design and engineering in my department. So we're actually the bridge builders in that area.
Excellent. There was an interesting question here, and this might be a nice segue to it because we're talking about the elements here. There's something about process. Do you guys run process simulations in your different departments? So whether it's LEGO bricks or whether it's other areas, mold making, etc. What are those process simulations like, and can you talk a little bit about that process?
I will be short. Sorry. So I'm gonna
go ahead, Camille.
So we run definitely the simulation. We also have like static evaluation and a calculation, because even the models are from Lego bricks. They are quite heavy. We are counting with 2-3 tons, and sometimes we need to put it on the wall. They need to be transported through the airplane, etc., etc. So definitely for us, the main things are the static calculation of the big elements. But also, since we have lots of like movements, electricity inside it, we have the electromagnetic discharges, how it is heating inside the Lego bricks, etc., etc. And this is more like we are only just one from many specialists in this industry. So we have the electro engineers, we have the mechanical guys, like they are working on assembling and disassembling. We have very specific specialists for the Lego bricks itself, if the elements are available or not available, how they are working with UV light, etc., etc. And there are, I would say, basically, we are kind of company inside the company. So there is lots of other things.
So lots of testing and
yeah,
testing.
and evaluation. You need to ship the material somewhere, so you need to have the packaging. You need to have some storage around it. You need to have like a handling material or a handling guideline how to operate with that. You have the range of the motion, so you are not in clash with other stuff. So it doesn't look like, in the marketing department you will do that, but compared to what I did before, this is the most demanding what I actually do, like the mechanical engineering.
Michaela, I imagine there must have been a lot of testing to get us to a new packaging. You want to tell us a little bit about that?
Sure. Once we are talking about modification of the packing lines, replacing the single equipment, or even doing some bigger intervention like changing it totally, it means you need to prepare your learning plan. So simply you go through all the transformation which you are doing with the product, and you are simply questioning yourself what are your possibilities to gain the confidence that this project will work at the end. So yes, for our project, let's say a big change in a packing side. So we went for prototype lines. So we were building the physical lines, but in the early stages of the equipment development, of course, you can use 2D, 3D, or even 4D layouts. You can go for mini testing that you have, let's say, typically at our supplier side. We build part of the machine and we test a critical transformation or movement of the elements. So this is how we are gaining the confidence that our concept is going to work at the end. And of course, time is typically limited and resources as well. So we use all this, let's say, tool to learn quickly. And at the early design stages, when it's cheaper to change it.
And I guess that probably plays into what Agnes is doing with automation. There must be quite a bit of process going on in automation as well, right?
Yeah, as I said, let's say Lego factories are very unique. You will not find the same packing lines running, for example, at the pharmaceutical industry or elsewhere. So actually, we are developing the lines on ourselves, and now we are cooperating with the single machine suppliers doing the integration by ourselves. So it's internal knowledge.
Right. We've got about 2 minutes left. I'd love to start with you, Agnes. I'd just like to go around, and if you could just imagine for a second, what would you tell someone who was looking for a career in mechanical engineering in the Lego Group?
I think the most important and essential in our positions, be curious and be brave all the time.
Excellent. Mandy?
Probably to ignite and keep on fueling the spark of creativity, because that's how you innovate, that's how you find new solutions.
Mm-hmm. Camille?
I'm lucky that I have like freedom of design. So whatever I do and persuade the client, they will buy it. I'm good.
Excellent. Jesper?
I would say from a practical point of view, we actually have a lot of supporting roles in Lego Denmark that supports foreigners coming to Denmark, applying for jobs. So that shouldn't be a hindrance for you to apply a job in Denmark. We have a lot of stuff and a really cool campus in Denmark where you can do a lot of cool stuff as well. So
That's
just
great.
apply.
There was a question in there about internationals coming in and how welcome we were. I'm sorry we didn't really get to address it, but thank you for bringing it up now. Michaela, what would you say to Just Imagine?
Yeah, I joined the Lego group through same event like we are just having right now. So I would say to everybody, just apply.
Awesome. That's great. And you can apply on lego.com in our careers page. We have all of our jobs listed there. So thank you all for joining today. You were fantastic, and this was a really wonderful discussion. I feel like I know a little bit more now about mechanical engineering. I love to come around and see what it is that you actually do. So thank you.
Thank you very much as well.
Thank you.
All right.
Thank you.
Bye.
See you all next time on Live.
Bye-bye.
Bye.
Bye.